So this is a Jacquard loom, invented in 1804 by Joseph Marie Jacquard. It used punch cards to control how threads were woven. So you have hole or no hole, 0 or 1. Lift the thread or don't. That's binary, that is. It's wood, but it's binary. So here are the punch cards. You make holes in the cards, and then it tells the wooden machine what to do. So here's somebody programming the Jacquard loom. They're making holes in the punch card. They don't have an IDE, they have a hole punch, but it's pretty much the same principle. And there's Mr. Jacquard himself, and this picture is actually woven using the Jacquard loom, and it required 24,000 punch cards. That's not decoration, that's a program. Here's the key idea, that the machine stays the same, but you can make any kind of pattern with it, because it changes when you change the cards. So the separation of hardware and instructions is the foundation of everything that follows. Then we get the analytical engine. Inspired by the Jacquard loom, Charles Babbage designed the analytical engine, a fully general mechanical computer. It had a store, memory, a mill, which is like the CPU, had conditional branching, it had loops, had punch card programs. All of this in the 1830s, entirely mechanical, powered by cranks. He planned to make it powered by steam, but he died before he got there. And his friend Ada Lovelace went even further, realising the machine could manipulate symbols, not just numbers, but she talked about like music, text and logic. Unfortunately, that analytical engine was never completed, but the architecture was right. Software was invented before electricity. Fast forward a century to Bletchley Park. Computation becomes urgent. During World War II, machines like Bomb and Colossus were built to break encrypted messages. These were not completely general computers, but they were programmable, electronic and fast. For the first time, computation ran continuously. Machines failed and restarted. Operators, workflows and scheduling mattered. This is where computing stopped being theoretical and became operational. After the war, all these code breakers went to universities and they made more computers. Here's the Manchester Baby, which is the first stored program computer. The program lived in memory, not in wiring or switches. And then each university got their own computer. Computing turned into a service that researchers could actually use. This is the turning point. To change what a computer does, you load new software, not rewire the machine. That single idea made operating systems inevitable. So after universities, the commercial world got involved. IBM industrialized everything. They standardized mainframes with hardware compatibility, batch programming, job queues, accounting, uptime expectations. You wrote programs on punch cards, handed them to an operator, and came back, and the next day you see if they ran, or if you had a bug and you had to punch all the cards again. But this is where operating systems quietly formed. You had job control, memory management, IO abstraction, all before users ever saw a screen. With this IBM mainframe, people then used it to write CTSS, the compatible time-sharing system. What a well-dressed coder, I have to say. They've come to photograph his computer, so he turns out in his evening wear. With the IBM mainframes and the other machines before that, you had a stack of cards, and the operator ran them through the machine, and then they did the next stack, and then they did the next stack, and then they did the next stack. It wasn't interactive. But then with CTSS, we had time sharing, which you might call in modern ways like concurrency or async IO in Python. Doing several things at once, switching between tasks to simulate everything at once. So instead of one user at a time, many users shared one machine interactively. The computer switched between users, giving the illusion that everyone had their own machine. So this introduced multitasking, logging sessions per user files, real-time interaction. Every modern operating system descends from this idea. You sit at a computer, you type your command, you give your command, and you got the result back in real time. So instead of giving the stack of cards and coming back tomorrow, you run your command, and then somebody else runs their command, and somebody else runs their command, and somebody else runs their command, and the computer switches between. So while somebody else is busy typing the next command, it's operating somebody else's command. So when you type your command in, the computer operates it, and when you're typing your next command, the computer has switched and is processing somebody else's command. So you can have lots of people working at once, each with different tasks, and the computer switches from task to task. They followed this up with RSX11 and Multics in Bell Labs. So on the Multics system, they wrote Unix. And Bell Labs was part of AT&T. So AT&T, the American Telegraph and Telephone Company, whatever it is, it was like a huge monopoly. And it was difficult to tell where the AT&T ended and the US state began, so they split it up. But before that, they had the research element of it was called Bell Labs. Ken Thompson and Dennis Ritchie wrote Unix on the Multics. On Multics, they wrote Unix, which replaced Multics. and it was small, simple, it was portable. Instead of writing your code in assembler, or which we call A, and then they, as assembler, wrote the language B. Dennis and Ritchie wanted an even higher level language, so they wrote the language C. High level for the time. Unix spread everywhere, not because it's perfect, but it was good enough and adaptable. But then AT&T was broken up and they started charging for the operating system. So AT&T became System 5, which then became AIX and Solaris and HP Unix. It was all proprietary and really expensive. And until this point, you'd always had the source code. And suddenly they wanted to give you the binaries and charge you for them. So the universities weren't having this. So they built BSD, but you had networking and a cleaner design. Bill Joy there, who also went to be the founder of Sun Microsystems, he was one of the original founders of BSD. With BSD, they took the last free version of Unix. But to be completely watertight, Richard Stallman wrote GNU, and GNU stands for GNU is not Unix, so it was a complete clean Roman interpretation. AT&T Unix, which then becomes System 5 in all these proprietary systems, and then you have Xenix, which eventually gets bought by Microsoft, and then you have a BSD in the universities, you have GNU in the universities as well, and people operating, collaborating by post, and then you have all these home systems like the Amiga happening. The universities were getting pretty close to working Unix, and they decided to make a kernel that would work, a new kernel that would work for BSD and GNU, and they called it Mac. Carnegie Mellon University in Pennsylvania, where these were, they were inventing Mac, which was going to be a kernel that was going to be used by BSD and GNU. And then GNU was going to wrap Mac with services, and that was going to be called GNU Herd. BSD, they had some good development in the original kernel and decided to go with it. While Richard Stallman and the GNU project were trying to get this Mac Herd thing going, he never ages because he always looked old. Linus Torvalds needed something to work on a consumer grade PC, so he invented the Linux kernel to kind of tide him over while he was waiting for the GNU project to finish. And Linux, it ran well on cheap PCs. Linus accepted patches from the community by internet took off. He, at just the right time, he accepted them by email. The new technology of email, he accepted them. Linux ran well on cheap PCs, it accepted patches, it shipped early, it scaled socially. So as more and more people contributed, you know, it built a hierarchy, a natural hierarchy of competence and meritocracy. And, you know, somebody would become a maintainer of the file systems, and then somebody in the file systems might be a maintainer of this file system, and somebody might be a maintainer of networking, and then inside that somebody might be a maintainer of that network. And it wasn't aiming to be elegant, it was aiming just to be performant and just to work, just to ship as early as possible. So it didn't win by elegance, it won by momentum. It steamrolled over GNU Herd, and it steamrolled over BSD and steamrolled over everything. So then Linux was then distributed on CDs and then on the internet, and it formed into distributions. Different people distributing with different package managers and different pre-installed software and so on. But they're fundamentally the same system. OpenSUSE was an early distributor, Slackware, Red Hat was the corporate version, which then spawned Fedora, which was their community version, which then spawned CentOS, and then perhaps most importantly Amazon's Linux, which powers AWS. You know, this was fundamental. There would be no cloud without Linux. You had OpenSUSE, you had Debian, which was Ian Murdoch. His wife was called Deborah, so they were known as Deb and Ian, or Debian. So it's not Debian, it's Debian, because it's Deb and Ian. Mark Shuttleworth came and wanted to put more polish onto it and make it easier for users, and you had Ubuntu. And then people wanted to make it even easier and made Mint and Pop OS. And then Gentoo was for hardcore users, and Arch as well. And then you have all kinds of distributions coming all the time, like the meme kind of influencer based on Vim operating system Omarchy, which I thought was kind of fun. And then perhaps the most important Linux distribution of all, which is Android, which is then like a big commercial Linux on these Pixel phones and other phones. Billions of devices all running Linux. The community then comes back and tries to make Android community distribution again. So you have like Graphene OS with security and like Lineage OS that makes older phones work much longer than the manufacturers do. And Linux is basically it's the winner operating system, really. Everything once you get into Linux, everything else seems a little bit like the past. I mean, Mac OS, which we'll get into in a minute, they have the design chops, But as a developer and as a power user, there just doesn't really beat Linux. It's just in the control, it's a completely open system. Even if you're not a programmer, there might be other people with the same needs as you, and they can make it work the same. So it's just like another generation on than all the other operating systems, really. And the difference is just growing all the time. So the other operating systems aren't going to catch up. For the period where Steve Jobs was in exile from Apple, he made Pixar, the animation company, but he also made Next Step. And these other distributions were Linux, and the free BSDs and stuff were around, but he basically didn't want to share. He wanted the option of not sharing. So he took the BSD kernel, not sharing. So he took the BSD user space from up here, the old BSD user space from up here, and he also took the Mac kernel that the BSD developers had rejected and that the GNU system tried to use but had been sidelined by Linux. He took that Mac kernel, that rejected Mac kernel, and it became the cornerstone of the Next Step operating system. And then when the original Apple OS and the version 9, which I actually thought was really good OS, it kind of reached the end of the line, and they were looking for a new operating system, and they were going to buy BOS, but BOS were asking for too much money, and so Apple were trying Linux. They were trying to make their own Linux distribution. They did make their own Linux distribution, and they distribute their own Linux distribution, and you could get an you could upgrade Apple machines to MK Linux. It was called Macintosh Linux, MK Linux. You could upgrade the OS 9 machines to MK Linux. That was the upgrade path. And then Steve Jobs came back into Apple, and he brought the Next Step operating system with him, which he combined with Darwin, the bits from FreeBSD, and it became the Mac OS X system, which obviously powers the Mac, but also the iPhone. So millions of these as well, hundreds of millions of these around the iPhone. So Mac actually, what made it really bad at desktop made it really good for a phone. It was really, small, micro, not as performant on the desktop, made it really good for a phone operating system. So the Mac operating system continued. Meanwhile, in another planet, we go from RSX to VMS, and then VMS and Unix, form called Xenix, ended up in the property of Microsoft, and Microsoft's Win98 operating system, kind of based on around DOS, that was also running out of steam, like Apple's OS 9 kind of ran out of steam. The DOS-based Windows ran out of steam. So they took Xenix, they took some ideas from their Xenix product and the VMS product, and they made Windows NT. And then Windows 2000, and then XP, and then Vista, and then 7 and 8. They couldn't make a 9 because the hardware detector library said, if the operating system starts with 9, then it's Windows 98. Do that, whatever. So they went straight to 10. And more arrows you could build, because the developer tools on Windows are based on Ubuntu. So the developer tools are increasingly based on Ubuntu. So a lot of the Linux stuff is just too good to not use. So it ends up in Windows. And Microsoft said Windows 10 was going to be the last Windows they made. But then they made Windows 11. But they're aiming to replace Windows with Copilot, basically. And it's interesting that Windows itself, because Microsoft in the Bill Gates era were really against Linux. In the Satya Nadella era of Windows, they are really into cloud computing. They make all their money from Azure, and I mean GitHub is a more important brand than Windows really today. So Microsoft 360, it's which then also been replaced by Copilot. So he's much more interested in cloud computing, AI, GitHub, You know, that's Windows is, but also Bill Gates was really anti-open source and really against Linux, whereas the modern Microsoft are like embrace open source and embrace Linux. So VS Code, one of their big programs, is open source project, and basically Windows is basically becoming an open source project really slowly. So the UI framework today, which is called Microsoft WinUI 3, it's being developed on GitHub in an open source manner, and it's kind of smart because the people who want to make Windows desktop apps basically can pitch in and help maintain Windows. So Microsoft, which is, as I say, more interested in cloud computing and more interested in AI and more interested in other stuff, they can basically outsource Windows and, you know, bring in more open source, and eventually it'll just end up being a wraparound Linux, won't it? And it's the same with the Mac as well. I mean, they have the really pretty UI, but behind the scenes, more and more of it gets replaced by things that are also in Linux. The open source community is it's just more powerful than a company, than one company. Even Microsoft is developing stuff in the open because collaborating with other people, peer review, you know, working with the people who use the product. You know, I mean, Microsoft, I think, would quite happily just make all its apps as web apps and then have a desktop version with Electron. But, you know, so people who want native, well, what is native in Windows nowadays, but people who want C# or C++ apps with WinUI get involved in making the framework themselves. So, you know, Microsoft is developing this stuff in public with the users, you know, which is really, really powerful and great. But it's also just a sign that the kind of Linus Torvalds model is just working everywhere. I mean, to be honest, Satya and Nadella is just a lot smarter than Bill Gates. Bill Gates was like a cunning businessman with making cunning deals, like the cunning deal with IBM to control the operating system of the IBM, but it wasn't going anywhere. And, you know, all the stuff that was going anywhere was Satya Nadella anyway. So, I mean, modern Microsoft is him, really, isn't it? But yeah, in under his reign, they are much less hostile towards Linux and open source. I mean, they happily run, you know, people pay to run Linux apps on Azure, and Azure partially runs on Linux as well, and it's all combining, really. Linux is just going to take over everything. So no, it's just because you have all this experimentation, and then you find the right solution, and the right solution is Linux. And it takes, you know, like business teams a while over here in the Windows world to figure it out, and it's going to take people who like pretty buttons in this Mac OS world some time to figure it out. But Linux is the present and the future, and a lot of people are just living in the past. It's just inevitable. It's just like these things chip away. It's like the UI and the software on all these is all Linux, right? All these BSDs. The software behind the GUI is all kind of open source, Linux community type stuff. I mean, Mac, you know, Apple do give money in their own way. So, you know, like they wanted the Linux's print server on Mac famously, so they just bought the company, you know, they bought it out, the software. So, you know, so they didn't have to, like, at the time they didn't want it to be as open source, so they just bought it, and they had a commercial license to use it because they'd bought the people who make the Linux print server, so Mac could print things. And it's like that all the way underneath. You know, the compilers are the normal, you know, LLVM or GCC. You know, it had Emacs in it for a long time. There's nothing more GNU than Emacs is there. It had Emacs built on the system for a long time. I mean, when you dig through, a lot of it is okay. So you go like open source at Apple. Open source software is the heart of Apple platforms and developer tools. Apple works with developers around the world to create, contribute, and release open source code. So Swift language is open source. Container, a WebKit. I mean, WebKit started as KHTML, and then became WebKit, and then, you know, becomes Chrome. So you can access the source code for operating system developer tools by downloading releases or browsing Git repositories. So, you know, I mean, they're using Git. Windows is using Git. If you open Visual Studio, it's all based around Git, which is by Linux Torvalds, which was created, you know, Linux Torvalds creating Linux, created Git in order to work on Linux, and now it's at the heart of Mac OS X and Windows. So they have array support for Python, key value stores, they've got research stuff, they've got machine learning tools. So Apple is, you know, is only getting, Mac OS X and Windows will only get more open source. There's not really any value in keeping stuff to yourself and not being able to share the load, you know. Being able to share the load with your users is what made Linux successful and is what makes anything successful, you know. Even something with the resources of Microsoft, they want to share and they want to have, you know, contributors.